Hello students. Today we are going to learn part 4 of chapter number 12, that is Heron's formula of class 9. Okay. So in the previous part we have learned some different type of examples. Now today also we are going to learn a different example. Okay. So let us start it. So here it is given that a field is in the shape of a trapezium. Okay. Whose parallel sides are 25-meter and 10-meter. The non-parallel sides are 14-meter and 13-meter. We have to find the area of the field. So as per the condition, let us first draw that figure. So since it is a trapezium, so it must be somewhat like this. Okay. So this is our required trapezium. Now it is given that the side of the field whose non-parallel sides are 25-meter and 10-meter. So let us consider that this one is 10-meter and this side is 25-meter. Now further it is given that the non-parallel sides are 14-meter and 13-meter. So let us consider this one as a 14-meter and this one as 13-meter. Now we have to find the area of the field. Now remember that this one is a trapezium. For finding area of a trapezium, we should know its height, that is the distance between these two parallel sides. Okay. For that, what we have to do, we have to make some changes in this figure. Okay, so now what type of construction we are going to do? First we are going to draw a line which is parallel to this 14-meter. Okay, so let us consider that this one is a line which is parallel to 14-meter and equal to 14-meter. Now if this one is a 14, then this one should also be 14-meter. Okay, now remember that since these two sides are parallel to each other, these two sides are parallel to each other, so this figure, it becomes a, yes, it is a parallelogram. Okay, so if it is a parallelogram, then we can say that the distance from here till here, it must be 10-meter, and this should be the remaining 15-meter. Why? Because the total distance is 25-meter. Okay, so if this is 10, so this should be 10, and this will be 25 minus 10. Okay, now what we will do, we will find area of this triangle first. Why? Because we are having three sides. Once we are getting area of this triangle, we can easily get its height, and after getting that height, we can find area of trapezium. So what are our three steps? First, let us write it. First, we are going to find area of triangle. Then second, from that triangle, we are going to find height. Okay, and next we are going to find area of trapezium. Okay, so in these three steps we are going to solve this example. Okay, so now let us remove this figure and get the original figure with this. So now if we make the construction somewhat like this, we will get it. Okay, now in this figure, ABDE is the required trapezium, where AB is a 14. Okay, this AB is a 14, therefore EC is also 14. AE is 10, so BC is also 10, and this ABCE becomes a parallelogram. Okay, now in this triangle ECD, this side is a 14, this side is 13, and CD is 15. Okay, so we'll find area of triangle first. Okay, so now let us start it. Okay, so now here what condition is given? In figure, ABDE is the required field. So this ABDE is the required field. What we have done, we have drawn EC parallel to AB, and we have drawn EF perpendicular to CD. Okay, these two construction we have made. Now in quadrilateral ABCE, as per the construction, AB is parallel to EC and AE is parallel to BC. Okay, therefore ABCE is a parallelogram. Now since it is a parallelogram, AE will be equal to BC. Okay, so If AE is 10, so BC will be how much? It will be also 10. Okay, so that we have written here. Then after that, if this value is 10 and the total value is 25, how to get CD? So CD will be 25 minus 10. So CD is how much now? 15 centimeter. Sorry, 15 meters. So that value we are having over here. Now, what we have done now? For this triangle ECD, we have to find its area. Okay, so for finding area, we are having the three sides. Let A equals to 13, B equals to 14, and C equals to 15. Okay, so we have written it here. So now A equals to 13, B equals to 14, and C equals to 15. Now for finding area, we will find it by using, yes, Heron's a formula. So first we need to find what is semi-perimeter. So semi-perimeter S equals to A plus B plus C upon 2. So 13 plus 14 plus 15 upon 2 is equal to 42 upon 2. So that equals to 21 centimeter. So now our semi-perimeter value is 21. Now using Heron's formula, area of triangle ECD will be equals to under root S minus A, S minus B, S minus C. Okay, so we have S value 21. Now S minus A means 21 minus value of A is 13. Okay, 13, then 21 minus 14, 21 minus 15. Okay, so after the subtraction, we get 21 as it is now. 21 minus 13, 8, 21 minus 14, 7, 21 minus 15, 6. Now, what is our next step? We prefer to find, yes, the prime factors of this one. We factorize this one. So 21 can be written as 7 into 3. 8 can be written as 2 into 2 into 2. This 7 as it is, and this 6 can be written as 2 into 3. Now we will arrange it in the increasing order. So this 2 is 1, 2, 3, 4 times. So we have written here 4 times. Then 3 is 1, 2 times. So we have written it here. And 7 is also 2 times. So it comes over here. Now we have made the pairs. If we are getting pairs, then we can write it out of the root. So almost all numbers are getting pairs, so we will remove the root. So now here we get 2 into 2 into 3 into 7. So 2 2s are 4, 4 3s are 12, 12 7s are 84. So what is area of the given triangle? So it is 84 meter square. Okay, now we are having this area of triangle. Okay, this triangle area we have, how much it is? It is 84 meter square. Okay, now we have to find, so now we need to find this perpendicular. Why do we need to find this perpendicular? Because if we are getting this perpendicular, then we can easily apply it for area of trapezium. Now we have another formula for finding area of triangle when perpendicular is given and this base is given. That is what? Half into base into height. Okay, so area of triangle ECD equals to half into base into height. Okay, so further what you will get? Now, what is our base? So area of triangle ECD, that we have 84, so we have written it here. Now base is how much? So base is CD, its value is 15. Okay, and height is how much? EF. Okay, so that value is unknown. So we get 84 equals to half into 15 into EF. Finally we get EF equals to 11.2 meter. Okay, now what we have to do? We have to find, see, now look at this figure. Now we have a value of this height. Okay, now since this full figure is a trapezium, we can find its area, that is area of trapezium equals to half into s1 into, sorry, s1 plus s2 into height. Now what is s1 s2? So that is nothing but the sum of parallel sides. So first parallel side is AE, second parallel side is BD in this figure. Okay, AE its value is 10 and BD its value is 25. Okay, so we get half into 10 plus 25 into, now this height, okay, EF is how much? 11.2. So further half into 35, 10 plus 25 will become 35 into 11.2, and our final answer is 196 meter square. Okay, so in this way, what is the area of trapezium? That is 196 meter square. Okay, so suppose what we have done, so whenever you are getting a condition that you just have a trapezium, okay, with these two sides given and the non-parallel sides given, at that time how to find it? So first we have to draw one line parallel to any one side of a trapezium, then find its area of triangle, and then height, and then area of trapezium. Okay, so this much is enough for today. Thank you, have a nice day.